Hey everybody, welcome to the Oregon State University Permaculture Design Pro class. This is the fall and summer and fall. Yeah, summer and fall class. There we go. And we're coming into our fifth session and we're coming on to our fifth week. So currently no questions have been logged. So I think what I'm going to do is I'm going to overview the water assignment and kind of expand upon some of its details, because this can be, especially when it comes to permaculture design, this can be the make or break conversation. So let's jump into it and kind of detail and drill down. Okay. So one of the first things you'll come to is the water survey. And basically what the water survey is trying to do is give you a sense of the bigger picture. What's your drinking water? What's your wastewater? Now, if you're in a municipal situation, this is going to be pretty easy. You're going to research this and find this and get into detail on it. If you're in a rural situation, chances are you're going to work on understanding your well. And some places have well logs. In Canada, at least in British Columbia, it's required to have a well log. And that means your well has a tag, it has a number, and then you can research it. I found working in the US, some states adhere to that and some don't. And then, of course, there's the variability of installers. And even if they are supposed to log their wells, they don't always. But what's great about if you do have a well log is that there'll be a lot of information in it to utilize in terms of what's the depth, what are the different parent materials, and at what depth are they at. Um, Generally, when are they seeing water? How deep is the well? Things of that nature. So if we take a look at ADIOS, we've got conversations about a private well, its depth, its pressure, its flow, if it's electric or not, when the annual water testing was, things of that nature. So quite a bit of good detail. And then in terms of wastewater for her, it was septic system, household water, pumped 3 to 5 years, materials pumped out, where do they go, what's that whole conversation. So that's the drinking and waste. And then rainfall, just a quick reminder to get into your 24-hour rainfall and your yearly average, or close as you can find. Some of this data is not available. So just make a note, could not find this data, or spoke to the local farmers, spoke to my neighbors, things of that nature. Impact, so what does it look like when this site or this area gets a major precipitation event? And so this is an opportunity to bring in images and do a little research and show the show that piece there. And then what are the roofing materials? Now, if you have a surface you're going to be calculating, I want to know what the roofing materials are. So if this is a shed, if this is a house, if this is, it doesn't matter. I want to know what that material is. So make sure to put it on and let me know how old it is. So there was a study out of Sweden that showed that after 5 years, the off-gassing of asphalt shingles was complete. And after that, it was relatively safe to harvest rainwater off of an asphalt roof. Up until that first 5 years, there tended to be a contaminant issue. So we want to know what those elements are. So again, SWOT for water survey is, a weakness could be only dependent on municipal water for those in rural situations or in urban situations. In rural situations, it could be that it's a low flow well. I just did a 25 acre or 35 acre walkthrough with a client. Just wanted to walk and talk, and we walked and talked, and their well was low flow, quite deep, but they had tons of surface water. And so we devised some strategies for him to explore on his own to start to capture and store water on his property and start working with surface filtration. So watershed maps, some folks are missing this, but this is the micro watershed practice sheet, and you have to show us, as the instructions say, for the design site yellow box, draw in the watershed boundary, the watershed basin that encompasses, and the water flow lines on this map. Now, If contours are a total surprise to you, I've made this entire video here that'll go through this point by point. But basically, and this is true for all, um, this is true for all basins and all watersheds. We're going to start at the bottom of this design site. So we can see here we've got 470, 460, 450. So it's going down in 10-foot increments. And basically, this is important here. Water flows at right angle to contour. So basically, you can come up from this bottom piece and just start going at right angle to contour. Because basically, what we're trying to do is work with the fact that water flows at right angle to contour. Now, when we get to areas like this, we don't really know what's in between here. This is contour lines are a guess in between different elevational points. So when we get up to the top here, we could theorize maybe here generally would be an issue, but then in between we don't know. But this is what we would call a saddle because it's in between 2 points, and then we would come back down this other side, and then to the high point again. This is a saddle, so this is a low point and a high point, and then again coming down right angle to contour. People sometimes get this wrong, that going in between these saddles. So just make sure you do cut the difference between them. You know, we're working to be roughly right instead of precisely wrong. Now I'm going up to the top in the middle here because again, basically the top of whatever this mound form is doesn't break the 10-foot line. So we don't know what's above here, but generally looking at the shape, we can think that these are going to, this shape is going to come up to 2 points or 2 knuckles. So I'm going to basically cut the difference there. And again, come over here, again, right angle to contour, right angle to contour, and coming up. And I'm going to come back down here. And again, I'm going to go right angle to contour. And the reason for that is water flows right angle to contour. So, and then once we get to this top line here, this is basically a ridge and it's going to divide itself. So we can basically cross that line. So this would be the watershed boundary. Inside would be the watershed basin. And then we would go about starting to draw the flow lines. And generally, we're looking at these valley forms and the way and how these valley forms come. And so you can start to see there's these little drainages that come up from it as well. Any drainages here, maybe a little tiny bit. Oh, pardon me. Maybe a little tiny bit here, little valley form. And then we can see it kind of comes up this way. There's a little bit this way. There's obviously a little bit this way. So that's that microshed water sheet. You have to do this. You have to go through this process. Obviously, we want you to succeed because not only did I do a video, but I also explained it to you again. So you'll find time and time again, this is not a course about making an Olympic moment and having you vault over something. We're trying to help you to understand this process. So what you'll do is you'll take the same concept and you'll put yourself into that macro. So generally we're looking for in that macro watershed, where are you? And so in this situation, we've got the Catawba River. So we've got this big watershed. So where are you in that big watershed? And then where's the micro watershed? And so this is really specific to your site. Now, you'll see in the example that I give in the tutorial, the micro watershed for an urban site is not necessarily going to be constrained by contour. It'll mostly be constrained by urban infrastructure and gutters and things of that nature. Now, Adria is actually on a ridge. So there's actually no water that flows onto her landscape. And every once in a while, you'll see a landform like this. But what she has done, which is great, is she's shown us the high points in and around the area, and she's drafted up these different watersheds, which was brilliant. It was a great way to showcase a little bit more of the site and just get a little bit more value out of the assignment as a instructional piece. And then she zoomed us out and she showed us exactly where are these ridge lines and these different property boundaries and these different flow lines. So this is one of the things that PA Yeoman's taught us, is that we can decode a landscape by taking the ridges and taking the valleys, and each of these surfaces becomes like a roof pitch. It shows us those different elements in those different areas. This is a great example from, oh, they didn't put, oh, Michael. So here we can see that there's quite a bit of contours here. I think this is out of, yeah, the Vancouver Island area, which has great LiDAR mapping. They map the entire site quite a bit. And we've got kind of a top piece and then this watering coming all the way down. This is a great urban example. Pretty straightforward. Because roads crown, I talk about this in the tutorial, but because roads crown, you can really only take half of the road and then show us where those storm drains are. Any questions about the survey or the watershed map before I go to the rainwater flow analysis?
Yeah, I do. How do you get the topographical lines?
Yeah. So there's a couple of tutorials about that. But basically, when we get to topography, we are at the whims of the data that is pre-existing normally. So first and foremost, when I'm working in a region, I will Google search topographic or GIS and the name of that area. So if there's a county name, if there's a municipal name, if there's a rural area name, I'll type that in. That data is going to usually be at survey level or higher and give us information that we can use. Now, if there's pre-existing contours, that's great. If it comes to us in what's called the digital elevation model, we have to do some post-processing of that. So generally try to find just contour lines that you can copy and paste. There's two other ways that you can get common information, but be forewarned, the information from Google, which is generally the information we get through almost all second and third party distributors of this information, still comes from a shuttle radar topographic mission, SRTM mission from NASA in 2000. And that mission flew the world with light image detection and radar, LiDAR, and basically bounced lasers off the planet. And their response gave us a sense of the general shape of the planet. Now, each of those pixels was 30 meters by 30 meters, which means that there's an error of up to 15 meters on the vertical, the z-axis, and up to 5 on the xy. So if we take information from these sources I'm just about to tell you, we have to take them with a grain of salt, and we'll have to ground truth everything on site. And this is what we have to do regardless. So if I make a plan, even with sub 8 centimeter topographic information, if I go and lay out a alleyway cropping system or an orchard or whatever, I'm still going to go and lay that out in real time and use a GPS and find my points and all the rest of it. So I'm still going to get to accuracy that way. So there's something called the contour map generator, CHEUR or something. There was another company that took the name and created their own for a paid version, but it's the exact same data. So contour map generator here. Here we can zoom in and use an area of interest. So we can come in here to Guyana, and we can create a little area of interest by just drawing two squares here. Okay, I think it's taken half the planet, so we're going to reload that because that's a little much. Okay, I did it again. Oh, I think it's when I zoomed in the first time, it took someplace out in the ocean. Yeah, that's exactly what I did. Anyways, you can grab the corner of it and you can bring it over. And we don't need to take the entire region of Burkina Faso. There we go. That seems a little bit more reasonable, doesn't it? Okay, there we go. And then from there, you can get a sense of the number of levels, or what's the level of interval. Do you want to use meters or feet? And then you can produce this as a map. So you can you can save this as a map and take this out. So you can take this out as a KML file, which can be downloaded onto Google Earth, or you can download as an SVG or an image file. And then you can overlay that directly onto your property. Now, what's important to know here is that, and I just did a video with somebody, when this comes out, they come out as these colored lines. And oh, wait a second, I've got to click something here. Hold on. Get data. There we go. 2 contour lines. Okay, we're going to change that to 1 meter contour. Let's try that again. There we go. That's better. And then this is what it would look like. So I'm going to download that SVG file. I'm going to pull that back up. There we go. And then I'm probably also going to take a screenshot. Now, the reason for this is I want to be able to match this with something local on my site. So what'll happen is I'll take this image now, I'll bring it into Google Slides, I'll landmark it, make sure it's roughly right, and then I'll trace over these lines. And as we've talked about before, let's say that your property boundary is, let me just pull up this. Let's say your property boundary is something like this. In terms of tracing those contour lines, what we would do is pick a nondescript color, usually like a light gray works really well, or something that the eye can ignore. And what we'll do is we'll trace this in Google Slides. And notice that I'm tracing off the property boundary, because what you'll want to do afterwards is you'll want to label the elevations, but it's really important to label them off the property boundary. So that way, when they come in, into your design conversation, obviously my tracing is poor. When they come in, you're not going to get confused with having numbers directly in an overlay. So like this light blue is, well, let's start with red. It'll be easier. So that's the red, that's the orange, that's the next orange. So this is 256. This will be 255. If anybody want to applaud my amazing mouse drawing, feel free to. 253. 252. Oh, the skills you learn but do not need. 251 and then 250. So we would do all of this in Google Earth. And then what's great is you can delete that, the rainbow contours, and then you've got your contours online that you can start to work with. Now, if you're wanting to take a look at that big map, and kind of, where does this all land in the bigger scheme of thing, this is actually a great use of this program. So if we pull back now and we increase the size of this, and we want to get a better sense of, okay, what does this area actually look like? What is affecting this area? I'm going to get data for this. Okay, now we can actually see what's going on here. We can see this little valley form. We can see some ridges. We can see that there's this ridge coming over here. So we can actually start to place it into context. So we know that if this is the top here, and if this is our site, roughly speaking, I'm just going to draw on our supposed site. I'm going to use a circle this time. So let's say this is our site still. If we're trying to understand the influence on that site, we again do what we did before, and we go right angle to contour. And basically what we're doing is we're just coming up from this, finding that top point like here, up from this, finding that top point again, probably come all the way over here. This will flow off and out, off and out, off and out. My Canadian is showing. And then probably there, I probably wouldn't even include that. It's probably going to be right here. This is going to divide, and then we're going to get a bit of pickup. So that would be that micro watershed, the water that directly influences this. And then if you pulled way out, you would get a sense of the macro watershed. What is this area looking like? And so I'm going to clear this, and then we'll have to change from 1 meter intervals probably to 5. And then kind of get a bigger sense of this again. There we go. So I think we were someplace there, but now we're really starting to see how this influences in the greater conversation as we change those contours. So this is one of the places I like to get my maps. The other way to get maps or topographical information is, I'm just going to pull up.
I'm finding a lot that look like heat maps.
A lot that looks like heat maps. Okay, so they're gradated color.
Yeah.
Yeah,
Yeah.
they'll work. Yeah.
So you could kind of, what was it you said? Be roughly right about going, selecting some edges.
Totally. Yep. Anything like
Um,
that would be fine.
okay.
Yeah.
One other thing I just might point out is on the chapter 5 assignment resources.
Mm.
It looks like a number of the links need to be updated. They don't go anywhere.
Okay.
Under watershed resources.
So that's chapter 5, watershed resources.
Yeah, there's some under global and under US that haven't checked
Global
the other countries.
US broken links. Okay, thanks. I'll send it off to the team.
Okay.
So the other way to go about this, if you've got time, money, and conversations to work with, is you can actually run your own survey. So there's some constraints on this one. So this was a survey I ran for a colleague and friend of mine, Curtis Stone. He runs From the Field, which is like he calls it the Netflix for farmers. But basically what we did is his site, we basically ran a drone survey over using a third-party application called Drone Deploy. We also used Maps Made Easy. I ran it with both programs. I wanted to compare the two. And we did what's called ground control points. So I rented what's called an RTK, real-time kinetic total station, which basically if I leave in one place, and it's usually at the top of the property, if I leave it for long enough, that total station will basically find itself in relationship to the world and the different satellite constellations to like sub-centimeter accuracy. And I think it got down to like half a centimeter. So that point on the entire slope was as accurate as we could get it. And then I walked around here and I put on these little ground control points. And these ground control points basically were me taking a spray can and basically making a square and filling in two sides of that square. And then in one of those squares, putting a number. So like in one of these was 1, and then another one of these was a 2. And then we had a rover, which is a receiver that speaks to the RTK total ground station. And basically Javin walked along with a little flag and we took the center of each of these ground control points. So we've got the ground control points and we've got the real-time kinetic, and then this receiver, we can walk through the forest and we can take points. And basically the longer you hold the receiver, the more accurate it becomes in tree. Can take a long time because it can't see the satellite. So it takes a longer and longer time. And basically we took a number of points inside the trees. So basically what happens is the drone ends up covering the majority of the landscape that's untreed. So the drone covers all of this and is trued by those ground control points. And then us going through the trees with our little stick, our receiver, we then pick up as many points as we can. And then in post-processing, what happens is the drone goes through photogrammetry post-processing. So basically we can get to sub 8 centimeter accuracy on these open places. And then through GIS analysis, and I use a great guy by the name of Brent Smith with Paper Street Permaculture. He then unifies the data and has a proprietary algorithm that I also take the heights of trees and their sizing, and he's able to generally remove the heights of these trees and give us a digital elevation model, which then we can take contours off of. And so for Curtis, he actually has a really good video out on it. we had this one line that was coming through. I'll see if I can find it. I just have to make sure that I blur out his information. Give me one sec. We found this one line that was perfectly the amount of water that was flowing over his driveway, like to the centimeter. It was wild. Let's see if these maps, yeah, these are the ones. So I'll just let these download for a quick sec. Make available offline. And so it would be the catchment there. Here we are. Yeah, so this was wild. So I'm just going to zoom in and yeah, we're just going to zoom in and make sure we can't see the UTM coordinates. Perfect. Yeah, okay. So this was his site, and this is his pre-existing cabin, and now he's got this monstrous greenhouse, and then he's building his house here. But basically, these are what's called flow collection lines, and so each of these have a sense of how much area is flowing into them. So on the right-hand side there, you can see the catchment area. So these are meters squared. So basically, we can add to this any of our water metrics. How much water are we getting per rain event? How much water are we getting in general? And we can get a sense of how much water can we collect in each one of these little areas. So this little spot here where his road comes over and around through, perfect little runnel that was cutting off the road. And this was one of those places where he beefed up, put a little diversion swale here that came over here. And I believe he's got a little pond here that he's been renovating, which is coming along pretty good. But yeah, just pretty phenomenal to get this level of accuracy. We don't need that level of accuracy for most of what we do. And most of us who love being as accurate as possible are going to push to a level that we don't need. But it's important to have, especially when you start doing larger landscapes and you're placing homes on site and things of that nature. But great question. Okay, let's go back to the watershed map. So we talked about micro, we talked about macro. We've got that done. So in terms of water site flow analysis, we want to get a sense of your site. Where does the water flow onto and off of your site? Some situations, you're going to find that in urban sites, it's directly on. In other situations, you're on a ridge. In other situations, the water is flowing onto that site. So we want to get a global sense of this. Now, something you'll want to do with your roof structures is you'll want to label them independently for their downspouts or where downspouts might be. So you'll notice what Adria did is she made sure that everything went down to those specific downspouts so that way she could calculate. So you have to think about how the water flows at right angle to contour, if it's picked up by gutters, and then where does it go to downspouts? Because it's really useful to calculate to downspout, because generally that's what we're going to do. So there's another great example from Lauren here doing it, just taking it to those different layers. Usually we'll put in a precip chart. So what is that monthly precip? And then we'll start to put in what is the total area of site, average rainfall, and then we get what the total potential rainfall that falls or precip that falls on your site is. If you've been working in metric up to this point, continue. If you've been working in imperial to this point, continue with what you've been working with. Don't try and switch. You're going to make mistakes. And then you're going to have a small, tiny robot crash into Mars. For those that don't know, that was the big issue with one of the first Mars rovers, is some people were working in metric and some people were working in imperial. So just stick to one. Again, as always, if data is available, if you can't find this data, you can't find it. That's totally fine. Be aware that there are specific conversion equations, formulas for if you're working in imperial or metric. Once we get to our location matrix, basically we're going to put in that location, put in the material, the area, the average year, average or max 24, runoff coefficient. So we have a full runoff coefficient table here for you. So that runoff coefficient will give you a sense generally of the different surfaces, both permeable and impermeable. So you'll have to make your best guess with those and put that into your chart. Also, none of this, no dittos. We're going to have full complete charts or there's going to be marks that are coming off. Yearly runoff volume, putting that in, and then maximum runoff. So you'll basically get your results in liters or gallons. When I'm marking, I'll usually calculate the first one to see if you've got it right, just to make sure you're good to go. I don't recalculate them all. The one thing that I always tell people do and they don't is if you've done all this amazing area recoloration here. So if you change the colors here and they're appropriately color coded, do the same thing here. Just take that same color and just do a background fill on the cell. It makes it really easy when you come back to size systems, or if the clients are going to do it, it's just really great. And then below here, there's an opportunity to put the impermeable surfaces. So if you want, you can then come back and you can calculate, okay, so this is all grassland or forest land, and you can put that into your site here. So you can do the other paving areas, the permeable, or you can do impermeable. So you can do both. So if you want to get a sense of really what is that total water flow and capture and overland flow, you can. I don't know if I explained runoff coefficient all that well. So the runoff coefficient table gives us a sense of if 100 liters or 100 gallons of water fell on a surface, how many would flow off of it? So for some of these, like galvanized iron steel, there's a certain percentage, especially at beginning of rainfall, that will slightly be absorbed in even into metal or will evaporate. So it'll be 90% of those 100 gallons, 90 gallons will fall off, or an asbestos sheet, 80 gallons, or if tiled roof, 75 gallons or 70 gallons. You see what I mean? It's basically a coefficient, a percentage of how much water is flowing off. When we get to things like forests or woodlands, 0.05. And this is why this number right here is why clear cuts and forest fires lead to floods, because once we have forest fires, then there's no vegetative sponge, then the rains come, and then we have all of that erosive capacity. So this is one of the reasons why it's so important to keep anything that's bare soil covered as quickly as possible. I only have 30 minutes, so I'm not going to wax on about that, but this is an optional extra credit. And basically what you do is you take the total flow that might be flowing onto your site and you calculate that total flow. So that's basically taking your micro watershed and saying, and not saying, but calculating how much water is flowing onto or off of that area. And that's the water assignment. Any questions about that? Any excitements that anybody wants to share about the water assignment? Okay. Any other questions? We were light on questions on the sheet, so we've got some open time if anybody wants me to go over something specific to their design or question.
I have a question.
Yeah, go for it.
We don't get that much rainfall in Reno, but we do have water rights to one of the irrigation ditches here in town. So that's something that I'm new to. Started chatting with the neighbors and seeing what kind of systems they have for distribution. Most of the neighbors just have some fruit trees, or they're irrigating large portions of grass. That's all a gravity-fed system. So, what are some things to look at in this water analysis when we're dealing with this, irrigation ditches?
Yeah, so that would come under sources of water. So we'd want to know if there is an irrigation ditch, if there are water rights on site, what are they, or where are they coming from? You're in the States, right, Nico?
Yep, I'm in Reno, Nevada, and this
Reno.
water is flowing from Truckee River, Tahoe, which it goes from Tahoe to Pyramid Lake, and you siphon off of that.
Okay, so basically you're going to have an acre foot amount of water that you can pull off of that. And that's a volumetric. And from there, you can get a sense of where does it pick up, or do you have to go and source it? So in a lot of situations, what you'll find is you'll have a centralized location for this water, and then you have to access that water. So it's cost for owner to go and pipe to it, create a pump house, bring it down to property. Sometimes it's just a canal that you can feed
Yep.
off of. And maybe there's a lock box there, maybe there's a valve box or not. That'll be pre-existing.
So ours is an open canal. It flows in on the south side, and then we have a couple of these like cement blocks where we can lift up these little slides and we can irrigate the front field.
Okay,
And
so
then
it's
it
all
flows through the
flood
back.
irrigation.
Yeah, and then it flows through to like our front kind of field, and then it continues on to our neighbor. And so I think we have like surface water rights of like 8 acre-feet, but then lake ditch, we have like 2 shares, but it's not really like set on exactly how much water we can pull from this.
Okay.
It's very minimally managed. We're towards kind of the end of it. It's just kind of coordinating with the neighbors. We have a couple ponds that they fill up each year, and so it's pretty free flowing.
Well, you can reach out to the county and you can ask them what the rights are to that second source. It sounds like you know the first source. And you can understand from them what that second source is and what you can pull. Generally, depending on your landscape and what there is, I'm a bigger fan of having that feed in or top up top pond if necessary, and if possible. And then off of that top pond, then having reticulation pipes that basically run the property, especially in a place like Reno, Nevada, where your evaporation rate is so high. Flood irrigation is almost criminal. And as we're watching so much of the U.S. dry up, that's a problem. So what I would do is I would take the longest continuous highest contour on your site, map that out, and then take a look and see if there's a position somewhere along that line that a pond makes sense. And I imagine with your soils, you're probably going to be doing a lined pond. I imagine you don't have a huge amount of clay in your soils, right?
Yeah. And then we'd be lined.
Okay. So a couple ways to do that. You can line that with an EPDM non-fire retardant liner. EPDM non-fire retardant liner. The fire retardant's an issue. They started to put it into EPDM because they were doing roofs and things like that with it, which makes sense. But once it gets into water, it's a problem. So we don't want it with that. Or we can line with about a foot of clay. Now, the way to go about sourcing clay for a job that large is to contact your local gravel yards or gravel screeners. And usually what they'll have to do is wash the gravel. And if they're sourcing from a place that has clay, then you might get access to it. I'm not saying that it might be there. We've had great luck of reaching out to these folks, and for the cost of trucking, because it's a byproduct for them, we can take some out and then bring it in with an excavator and apply it at a foot depth. The other options are things like geo-woven impregnated liners that are impregnated with bentonite clay. And basically bentonite clay is a clay that swells to 10 times its size. And when it's sandwiched between these two layers, it means you can roll them out with machine. It's not something you can do with people. It's too heavy. And then you can seam seal it. I've never seen that work 100% effective. It's primarily that technology is primarily used for oil and gas and for lining tailings pond. It doesn't mean that the material, when it's fresh and new, is contaminated at all. It just means that's where the technology was created, and it's specifically created for very rectilinear ponds. So it's not really for like curvy ponds or curvaceous ponds or things of that nature. And generally what we'll do if we're creating a pond or an impoundment, we'll put a little bit of water in it, and we'll take the bucket of the excavator and we'll try and start to hard pack the bottom of that before we line it. Sometimes we'll get lucky and that'll actually help to close in that pore space and make it just a slightly leaky dam instead of just a big hole that drains into the ground. But basically once we can do something like that, then we've got some repository.
Yeah.
If we can't, a 5, a 10, a 15, a 20,000 gallon tank at the top of the property can be a nice insurance policy. All of these things you have to run through due diligence. Does it meet our goals? Does it meet our budget? Can we find
Yeah.
it? Can we install it? So none of what I'm saying you should take as go do. What I'm
Yeah.
saying is this is a potential solution and you have to do due diligence to see if it fits the context of your site.
Mhm.
Now, barring all of that, what I might do, depending on what you wanted to do on site, if you were thinking, well, I do want to start doing alleyway croppings, or I do want to create a forest of some sense, or food forest or
Mhm.
something like that. What I'd probably do is at interval place my swales with respect to what is the vehicle that might be harvesting, if there is a vehicle to harvest and a product to harvest from the trees, and two, doing what's called a sunshade analysis. So you see how everything's kind of connected now as we're getting into
Yeah.
more of the detailed design. So let's say our tree is, let's use really simple numbers. Let's say it's 50 feet tall with a 50-foot spread. Well, if we also have crowned respect, which means we're not going to allow our trees to touch, which is usually about 25 to 10% of that. So we're going to have 50 feet, 25, 25. So it's going to be a 50-foot canopy, a 12.5 spacing between that and the canopy of the next tree. So basically, what is that? 50, 25. So it's 17, 16, 62.5. Yeah. 62.5 feet from stem to stem. Now, when we get that distance, then we have to check it with our sunshade analysis. And basically, if we go back to our climate assignment and get our shade ratio, and we get our shade ratio at our different solstices, we can then project what is our shade cast going to be on these trees. So how far will that shade cast vertically and then horizontally onto the ground? And then we can get a sense of how spaced our tree rows are. So this little tiny question of make a couple of swales now has a whole bunch of other questions that come of it, because, well, why are we building the swales? To make trees. Well, why are we making the trees? Because we want to have timber or nuts or fruit. Okay, well, what is our solar real estate like, and how is it going to impact those other trees, so we can figure out where the spacing is? Oh, and how are we harvesting this? And if that shade cover, even an equinox, is really covering those back trees, well, then maybe we start to space our trees differently, and we do our very tall trees at the far north of the property, and then we step them down. So there's all of these moving parts. But
Mhm.
basically, if we make 2 swales or 3 or 4, then you could potentially overland flow into that first swale from your irrigation box, and then have that have a level sill spillway that would then overflow into your next one, and then sort of plinko down that landscape.
Mhm.
It's specific to each landscape, but basically I try as much as possible when I get to a flood irrigation conversation to be very conscientious of putting that water into productive use as quickly as possible
Mhm.
and not have it evaporate, which is the
Yeah.
nice thing about swales and trees, is trees shade swales and reduce the amount of evaporation when the swales fill. So,
Mhm. Yeah, I'm definitely seeing that on one side of our property
okay.
already. There's, a whole row of trees that are blocking a lot of the sun. And with all that water flowing, it's much cooler. You're seeing a very good microclimate on that end. But as they start moving, the water flows into this kind of open field area where there's no sun protection. It's just I don't know how we'd be able to distribute it in the same fashion without it all evaporating.
Yeah.
So we definitely want to do a pond, but it's figuring out how that could fit on the higher elevation on the property where all the structures are. I mean, our house is on the top of the elevation, and this whole cement pool area.
Okay.
So we got to figure out kind of the longer term of the structural plan of what we want to add, and see if we can fit the pond, and then what size it would be. So things to think about. Thank you.
Yeah. And if you put a question of, in your Q&A slide, looking at this and with our desire to have as much water storage and capture on site, or you have to give me some kind of boundary,
Yeah.
saying what would you do on this site? That doesn't give me the information I need. It's, well, we're thinking this, or we're looking at this. What do you think? What are you looking at? And from there, what I'll do is I'll use the annotation tool and I'll draw out what I'd be thinking in a landscape. But basically what I do is I follow the Keyline design approach. And Keyline is a full design approach. People have gotten the wrong idea that it's just the patterning of a landscape. And I think a lot of that's due to Mark Shepard's work, which great site, New Forest Farm, amazing, love what he's doing. But when it comes to Keyline, there's a whole design system that I think his focus on the geometry and the plow is kind of left by the way. Books for that are good to read, and you can find them at the Soil and Health Library for free online, is The Challenge of Landscape. That's probably PA's most digestible book. He writes in a pretty antiquated way. It's kind of like reading Alan Savory's original work. It's difficult to process. And then it's the 1978 or 68 Water for Every Farm, but it's a harder book to read. But basically in that, what we do is we take our contours, we mark out our ridges, we mark out our valleys, and then as we get these sort of roof surfaces, we then call that a land unit. And so that becomes an entire land unit because it has a fixed amount of annual rainfall budget. So we know in terms of this size and this amount of rainfall because of the water assignment, we have this much moisture to work with. Okay. Now then we can take a look at, generally trees are about an inch a week. So we need to be conscientious of either having that on land or having that stored in some way, shape, or form. Now, you can get into even further details by understanding what's called loading rates. And this is the amount of water that a type of soil can load. And this is always without respect to organics. So a percent of organic matter on 1 acre of soil can increase water holding capacity by 20,000 gallons. And this has been verified multiple times. Rodale Institute has done this a few times and has come up with, like, I think last time I read the article, it was 18,500 up to 22,600 or something gallons of water on an acre. So you can go into that level of detail, but generally, and this is why even PAA said it, if you generally get the pattern right, you get 80 to 90% of the value of it. Because if we increase organic matter, if we decrease compaction, if we increase plants and their storied effect, we're going to capture and store more water. Now, one of the things that PA was insistent upon, and I think Mark and others have held to this, is our drainages are immediately vegetated, and they go into almost like a pseudo conservation protection approach. We're going to vegetate them because we want to hold on to those drainages, because if we don't, and if they become bare, then they become incised and they'll unzip an entire landscape. So once you have channelization of water, as soon as it gets a drop someplace, it'll start to become a big drop, and then it'll move back and really like unzip. This whole landscape will just be obliterated. So his conversation was to vegetate those drainages, and then as much as possible, vegetate the highest points with native vegetation. So sometimes that's doing like a net and pan or an upside down smiley fish scale swale sort of a water harvesting system. Sometimes it's doing what's called fish scale vertical straw mulching, which if you go on to, we just did this amazing course with Neil Bertrando and Jeff Adams, and it's now a self-paced course. So if anybody's working in really arid climates, and actually Neil's really close to you, he's in Reno.
Yeah, I reached out to him, so I got his email.
Fantastic.
We haven't gotten together and chatted yet, but he actually taught my friend who was in his class too.
Oh, sweet. Awesome. Yeah. So yeah, if you go on to Regenerative Living and click on the LTEC course, Low Tech Erosion Control, this is the course, but what I'm directing you to is we did these number of case studies, and the one I'm talking about with the fish scale, vertical fish scale, where is it now? It was below. There we go. Vertical scale, fish scale straw mulch. This is brilliant. So basically in this, Neil did this amazing approach here. Yeah, we're not going to do that. But basically what he does is he takes a shovel And if it's, you know, if it's in this top ridge position, this is a hard place to vegetate. So basically he takes this shovel, opens up a little slit, puts like a flake of straw into it, and then pushes it back. And what happens is it's this little mini rainwater capture device. So water flows down here, a little bit of silt pulls up behind. And when that silt pulls up behind, now this is a place for vegetation to find and grow. And you see this regrowth that happens not just from the silt, but also from the straw that you've placed in, because you've placed in usually a little bit of living seed. So that can be another great way. But there's amazing number of ideas from all of these. Oh, and this is a great video, Burundi case study video. Natalie Topa, she generally works with displaced people in the Sudan, Kenya, Guyana. Great case study. It's on my YouTube channel, Flood to Food. And she goes through a number of different little case studies of how she built and stopped the water. She's great because she talks, especially when you're teaching folks who, you know, the jargon doesn't matter. Sometimes the language is really important. So she talks about making a water prison. And it's a great way to look at it, you know, like make sure that not a drop of water falls or leaves this property. It's funny, I said that in another class and someone was like, can we use another word other than prison? Sure, whatever works for you, I don't care. But have a way so that way that water stays on property as long as possible, and the transit time is as long as possible. So yeah, if you want more feedback on that, feel free. If you give me a really good water flow map, I can usually decode it and give you an idea of what I do in your site. And this is the other reason why we always give the full portfolio, because there's always more information to that. But
Yep.
Cool.
Thank you.
Yeah, you're welcome. Any other questions before we break? And I'll say this, it's a break. So as of the end of this week, so Friday, we're on break until the 26th of September. So it's quite a long break. Use the break, get ahead, do a lot of favors for future Adam, future Karen, future Nico, and future Caitlin. They will be very pleased with you if you get ahead now. Doesn't mean you have to finish or complete them, doesn't mean you have to submit them, but if you can get ahead, go through the tutorials, look at some back catalog of the office hours that's on our list or on YouTube, you'll be in a much better position. And generally what I would do is I would keep whatever schedule you have currently for your OSU time, or improve upon it so that way you've got 2 blocks of time that are deep work periods, anywhere from an hour to 3 hours, where you can just do a deep dive on your work, turn off the notifications, just be in what you're doing, and then touch it once a day. So 5 minutes where you open or look at it, 5 minutes where you watch something, 5 minutes where you read something, but just keep it alive. This is my approach. I don't know if it was this class or the other class. This is my approach when it comes to learning anything, is to keep it alive every day of the week and then have 2 deep work periods to go really deep. The other thing, which you could still do in this class, because we're only halfway through, is reach out and get a learning partner, an accountability partner that you can connect with and ask questions of and have a chat over the break. It's a great time to do it over the break because we've got the time. But just know that after this Friday, up until the 26th, I will not be marking and I will not be responding to emails. I am on vacation. So if you have questions up until Friday, this is the time. I will mark any assignments that are submitted up until Friday. So if you do get ahead and you're wanting to get feedback before the break, I will do that before Friday. So feel free to put those in. Questions, comments, queries, quotes, quotations.
Well, I guess I got one more one on the water.
Let's do it.
Another side of our waste is we do have a pool that we backwash. And currently that water is just piped out, and I put a bunch of rocks down to keep it from eroding. But that's just flowing out to the ground. I was wondering if there's, any ways or we've dealt with treating pool water, chlorine. We have a lot of like algae growth that comes into it because it's an old pool. The plaster's all deteriorated. Backwashing these filters is pretty gross. I wonder if there's any like capturing or storing it, running it through some kind of filtration system that could actually then be used again on the property, because we backwash it every 2 weeks and we're like probably 100 gallons full.
Okay. And what did you say was the chemical regime used in the pool?
It's a chlorine.
It's a chlorine or chloramine?
Chlorine pool.
Okay.
And then we do occasionally do this like black moss killer, which I think does add some metals. But we add this like a binding agent into it that's supposed to pull out some of the metals. But
well, I can't speak to anything I don't know, so I can't speak to the black moss issue. But if you did some research and let me know what was in it, I could have an opinion. In terms of the chlorine, if it is just ready milled chlorine, basically chlorine will eventually off gas. Takes a while, especially in that volume. But basically, in an urban situation, if I leave a pitcher of water on the counter in 48 hours, the chlorine's off gassed. So what you may want to look at is sort of transient holding tanks that are basically flowing out of and moving through vegetative systems, moving through living systems. And these would be systems that you probably would not be producing food off of until potentially the end. But basically you'd be looking at sort of a living system or a wet system. John Todd, I'll think of the other guy's name, but basically you're having a wetland that it goes through, serpentine, that over the course of it basically filters that water out. And it's not just the plants, it's basically the plants create a net, and the net of the roots hold the facultative anaerobes that are and aerobes that are working on the chlorine and the different material. And then probably at the end of that, I would put something like a wood copse, something where I'm not going to be eating that, but I could burn it, or I'm going to do pollinator habitat, or I'm going to do crafting material, willow, red oyster, dogwood. All of those create, live stake material that are really easy and good to use. But I'd probably do something like that and do sort of a staged conversation that would be influencing the site, but not detrimentally. And then the big question would then be, what's in that other one? And if you're working with heavy metals, then all of a sudden you're doing probably a longer transit time within that wet system, that wetland system.
Yeah, it's like ideally it's like one time a year we put that into it. It's not like a reoccurring thing.
Oh, I see. Okay.
Yeah.
So frequency is once a year.
Yeah.
Yeah, so
I can dive a little deeper. It was just something that came up when I was looking at wastewater. It's like and I backwashed it the other day. I'm like, that's a lot of water.
Well, it is.
Yeah.
You've just polluted it. Yeah, great question. And then I think the other thing as a bigger conversation is consider what the cost might be, or consider it as part of your design process or down the road of transitioning that into a natural swimming pool that has a wetland filtration system, something of that ilk. Yeah. Good question. All right, folks, it's been a slice. Have an enjoyable time with your Google Slides and your different videos and writings. If you have any questions before the end of the week, let me know. And don't forget to have fun with the course, because it's easy to get obsessive about this material. It's easy to get into a headspace of I'm saving the planet with my course. And while you are contributing to better steps, don't burn yourself out with the idea that it's only you. So take it easy, go slow, have a good time, connect with your classmates, and we'll see you in roughly 5 weeks.
Great, thanks.
You're welcome. Take care, everybody. Bye now.